Alright guys, good evening everyone. Please, if you're online, please indicate your presence. If you're online, indicate your presence if you're online. Alright guys, we are starting now. If you're active, please indicate that you're active. If you're active, indicate that you're active. Just indicate that you're active, so we can know those who are active. Okay, Emmanuel Obina, you are active. Alright, Franklin Charles, you are active. Please indicate that you are active if you are fully active. Indicate we are waiting for others to join. Please indicate. Indicate that you are active. Indicate that you are active. Please indicate your presence, that you are active. And I hope the board is clear, right? I hope the board is clear. I hope the board is clear. Is the board clear? I hope the board is clear. Please indicate your presence. Indicate your presence. Please indicate. We're waiting for others to connect. Please indicate. All right, we are starting very, very soon. Okay, 6 persons online. All right, guys. I hope the board is clear. Okay, we have 5 persons watching currently, so we're going to start immediately, so others can join us very soon, right? In our last class, we talked about friction, and we discussed in detail friction along horizontal surface, friction along inclined plane. All right. Then we also solved some problems in your textbooks. We solved virtually almost every question regarding friction in Imo State University textbook. And I'm so sure that there's no question that will come out in the exam that you guys cannot solve, because virtually I've done almost everything in that textbook. But the last part, before we go into what we have tonight, is that we what we want to do tonight is we'll focus more on physics 101 exam focus question, meaning I'll be picking random questions, solving past questions, and all that. And everything you are learning tonight, just take note of them. Okay? Then you can always go back to this video and study more on everything that we'll be discussing tonight. All right? Are you guys following tonight? So I want us to finalize on our last class. We talked about friction, right? I want us to finish up something. Something came to my mind. Like I said, I'm going to talk about dynamics of connected bodies on an inclined plane. I will talk about this briefly, then we go into something else. Dynamics of connected bodies, on an inclined plane, on an inclined plane, inclined plane. Now, when you look at this, the word dynamics, today we solve some problems in the textbook. A question came out that was last year, differentiate between dynamics and kinematics, right? Then we stated that kinematics talks about the study of motion of a body without considering the forces that causes the motion. Quite all right. Force causes motion, right? But the study of motion of a body without considering what causes the motion, which is force, is called kinematics, right? It's called kinematics. Then dynamics talks about the study of the motion of a body with respect to the force that causes the motion or that causes the body to accelerate. When it involves force, we talk about dynamics. Dynamics talks about the motion of a body and the forces that causes the motion. So let's look at dynamics of connected bodies on an inclined plane, meaning we want to analyze the forces that are connected, the forces that are involved when a body is kept on an inclined plane. All right. Now let's look at this. But take note that when two masses are connected, all right, by a string over a pulley system, when two masses are connected by a string over a pulley system, these two masses can actually move together as a single unit or as a single system, okay, with a common acceleration. Then we can be able to analyze the forces that act on this body. We can also be able to find the tensional force on the string. We can also be able to find the acceleration at which these two bodies move. For instance, if I have an inclined plane, right? Then we have a body here. The inclined plane has an angle theta, and we have a body here. Let's call this body the first mass, which is our M1. Okay. Then this body here is connected with another body over a pulley. I have a body here connected with this other body. I just want to explain this. Then we'll go into what we have for tonight, because they might give you this in the exam. All right, you might be giving something like this in the exam to analyze. Now, if I have a first mass and this is the second mass of the body, now don't forget that in our previous class we talked about motion along a inclined plane. That there's a force that causes sliding. The force responsible for sliding is simply this. Is a force here. Is simply mg sine theta. But with respect to this mass here, that force becomes what? M1g sine what? Sine theta. Please, if you are not here, If you did not attend the previous class, please go back to the YouTube channel. We have already discussed about motion along horizontal surface, the motion along inclined surface. They were looking at dynamics of connected bodies on an inclined plane. All right. So I explained that we have this weight here. This mass can be resolved into two, right? Into two. We can resolve it horizontally, which is m1g sin theta. We can resolve it vertically, which is um mg cos theta, right? Mg cos theta. Okay, or m1g cos theta. But in this case here, we are looking at the force here, which is m1g sin theta. Okay. Then this other mass here has its own weight or force, its own force. The force acting on this mass is acting downward, which is m2g. From the word force equals to mass times gravity, right? So we can analyze this force by saying that this is same as what? M2 times force of gravity. Because M2 is refers to the hanging mass. It's called the hanging mass. The hanging mass, okay? Any mass placed on this side is called the hanging mass. All right? We are connecting these two masses with a string. This is the string here. Don't forget that there is always a force that acts on a string. If I have a hanging mass that is acting downward, it's like having a pulley system here, and there's a rope, okay? There's a rope attached to this mass. Definitely the weight of this mass will tend to act downward, which is m2g, right? But there's something happening here. As the weight is acting downward, there's a force that is acting upward along this region here. That force is called the force of tension, or tensional force, or tension rather. Is a force that acts on a string. When you connect a body with a string, when the body is being hung on the string, okay, the weight of the body is acting down. There's a tensional force that acts in opposite direction, which is T. Okay. Then the next one is I hope you guys are following. Let me confirm if you guys are following. Please, if you are following, say I'm following. Please, if you are following, just indicate that you are following. Are you guys following at all? Okay, awesome. All right, so guys, let's continue from. Okay, let's continue. I hope the board is clear now. Okay, now look at this now. We are saying that we have two masses, right? We have the first mass acting this way, the second mass acting downward, right? Then for this mass here, the tensional force is always acting upward, right? Good. Now look at this here. If we are considering the motion of this body this way, let's say if m2g, if m2g, if m2g is greater than m1g sin theta, okay? If m2g is greater than what? m1g sin theta, this body will tend to move this way. Is that clear? It tends to move this way. But I'm also considering a smooth surface here. A smooth what? Surface. A smooth surface, meaning I'm neglecting friction. I'm assuming that there's no frictional force along the plane, that this plane is a smooth surface. That means the only force acting on this mass is simply m1g sin theta, while the force acting on this is what? m2g sin theta. Now, if m2g is greater than m1g sin theta, the motion will come this way, right? Okay. Now that means that there will be a tensional force acting on this body, right? The tensional force is the pulling force here. Is a pulling force because we are dragging this body towards this direction. So the tensional force we face this direction, right? Which is this. We call this what? T. The same value of tensional force here is the same value because we are using a pulley system, which is a machine. So that means that if my tensional force is 50 Newton the same tensional force will be what obtained on this side, which is 15 Newton. But the difference is that the tensional force here is acting upward because the body is coming down. Are you following? But in this case, the tensional force is acting this way because the body is being pulled. The body is being pulled. That means the body is obeying the tensional force. The body is obeying the tensional force because this body is being dragged towards this direction, right? It's obeying it. Tension is always saying, come this way. Okay? There's no way tensional force will act this way because there's no mass connected here. So that means tensional force will act this way. Then for this one, since the body is here, we have the hanging mass here. That means our tensional force will face the other direction. Now let's analyze the masses or the mass. Look at M1. If I'm to consider M1, okay, for M1, look at this now. Since we are considering the fact that M2G is greater than M1G sin theta, that means this body is moving in this direction, right? This body is moving in this direction from here to here. It's going this way down to this direction. So look at this now. The sum of all forces acting along this plane is simply M1G sin theta and tensional force. Don't forget that in our previous class, we said that any force that acts in the direction of motion is considered as positive, right? So it simply means that sum of all forces along this plane is simply equals to T minus tensional force is acting in the direction of motion. This is the direction of motion. If I'm to draw a free body diagram for this free body diagram, I will just bring up my hanging mass here. Look at this here. This is my direction of motion, right? The here we have here to be. We have here to be. This is my M1. Here will give us what? M1G sin theta, right? So we are looking at a case where this body is going up. This is going up. So my direction of motion is this. Is this. Okay. So I will say that the tensional force is also acting this way. Are you seeing it now? So for this now, for my free body diagram, you will notice that the only force acting here is following. If you are following, then I'm following. If you are following, I'm following. If you are following, just indicate that you are following. If you are following, just indicate that you are following. Please, all can continue. If you are following, indicate that you are following, please. All right, so can we now continue now? I hope the board is very clear. I hope the board is very clear, guys. So can we continue? Can we proceed? Okay, so we have seen that sum of all forces, the tensional force is positive. Then we have minus M1G sine what? Theta. Sine theta. All equals to what? The sum, according to the Newton's second law of motion, force is equal to mass times acceleration. But the mass we are considering here is what is M1 times what? Acceleration that we want to analyze. Then let's call this equation what? 1, right? For M2, for M2, this will give us what? Sum of all forces. Now let's look at M2. This is my direction of motion. Motion is downward. So the only force that is acting in the direction of motion is simply M2G. Why tensional force is acting against it? So here will be what? Equals to what? M2G minus what? Minus tension, right? All equals to the sum of all these forces is going to be m2a, mass times acceleration. But the mass we are considering here is our m2. Now that we have seen, we have gotten our equation 1 and equation 2. Equation 2 is simply this, right? So the next thing is to add equation 1 with equation 2. We add equation what? 1 and what? And equation 2 together. Why are we adding them together? Is to look for a means to cancel out our tension, because our aim is to find the acceleration of the body. All right, that's the essence why we are adding them together. So by the time we add up together, now let's watch. When you add up this side with this side, tensional force will cancel tensional force. Exactly. Let me bring it like that will give us T minus M1G sine theta plus M2G, right? We have T minus M1G sine theta plus M2G minus T, right? Minus T equals to, then I also add up this side, M1A plus M2A. M1A plus what? M2A, right? So from here, T can go with T here, right? Because we have T minus T, they will cancel out. We are left with what? Minus M1G sin theta plus M2G, right? All equals to, what is common here is acceleration. So we have A equals M1 plus M2. From here, we can rewrite this by putting the negative sign as the second term, right? Here becomes what? M2G minus M1G sin theta, all equals to A, M1 plus what? M2. Okay, so for you to find our acceleration, what do? We have to divide both sides by what? By M1 plus M2. Divide it by what? M1 plus what? M2. So this can go with this. We are left with what? Acceleration of the body equals M2G minus M1G sin what? Sin theta, right? All divided by what? M1 plus what? Plus M2. So this is the formula for finding the acceleration of the body as this body moves along this pulley system on a frictionless inclined plane. On a frictionless inclined plane. All right. Okay. I want to analyze. This is the formula, right? I want us to analyze something. Please take note of this. For those of you who want to write, just take note of this. But take note, the main formula is for this, right? The main formula is this. For a frictionless surface. For a frictionless what? Surface. All right. Now, let's proceed further. Let's proceed further. What if we have a rough surface? We have a rough surface. A rough surface. I won't go into the derivation. I will just show us what will happen if we have a rough surface. If we have a rough surface, that means that as this body is going this way, being pulled by this angular mass, frictional force will also tend to move this way. Exactly. Yes. That means that we have two forces here that are acting in this direction. We are dealing with a rough surface, meaning there is the presence of what? Of kinetic what? Frictional force. So that means that for a rough surface, this is very simple. Look at this. Since we have a negative value for minus M1G sin theta, right? Which is this. That means this will also have what? A negative value. I can go ahead and derive this again, but there's no time. But just take note that since this is negative, this must also be what? Negative. So my acceleration of the body will definitely be what? Will now be M2G minus M1G sin theta minus frictional force, right? All divided by what? M1 plus what? M2. But the challenge now is to know the definition of this frictional force. What does this frictional force represent actually? What does it represent? Let's define the frictional force. Then we'll solve a problem. Then we'll move into something else. Look at this. Frictional force, recall that frictional force is giving us mu R generally, right? Where we say that R is equal to what? Mu K mg. Sorry, R equals to value of R. Value of R is mg cos theta, right? So our frictional force here, which is kinetic, becomes what? Mu K mg cos what? Cos theta. But you have to take note that since the frictional force is acting on M1, so that means the mass we are considering will what here will be M1, not M2. But M2 have no influence. There's no frictional force affecting M2. Frictional force is only opposing what? M1. So that means our frictional force here, which is our Fk, right? We definitely be what? Mu K M1 G M1G cos what? Theta. Therefore, we can define our acceleration to be A equals to what? M2G minus M1G sine theta minus, then the next is to define frictional force, which is our mu K M1G cos theta, all divided by M1 plus what? M2. All divided by M1 plus M2. We can go ahead and also we can see further to factorize between this and this. What is common, right? What is common between them? What is common between them? What do you think will be the results of their common factor? What is common between them becomes what? We're going to have here to be A equals to M2G minus M1G is actually common, right? Minus M1G in brackets. Then we'll be left with, I guess that should be, if M1G is common, here will be sine theta minus mu K cos theta, right? All divided by M1 plus what? M2. So this is the acceleration of the body over a pulley system on a rough surface, right? When we have a rough frictional, a rough inclined plane. Is that clear? Or we can use this formula to solve. Now let's solve a problem. Let's solve a problem. Please, is it board? See blur? Is it clear now? Please, I need the response. Is it clear now? Is it clear now? Is the board clear now? Please, I need the response. I need the response. I need the response. I need the response. Is the board clear? Is the board clear? Please, is it clear? I need the response from you guys. Is it clear now? Is it clear? Just tell me it's clear so we can proceed. Tell me if it's clear so we can proceed, please. Okay, let's proceed. Right? Let's proceed because we are done with this already. Let us solve a problem, okay, on this. We have a problem here we would like to solve regarding what we just learned now, and I'll be very brief with it. The question says a 4 kilogram block sits on a frictionless 30-degree inclined plane. Please, is the board clear? Can we proceed? All right, so let's proceed. This is clear. The question here says a 4 kilogram block sits on a frictionless 30-degree inclined plane. The mass is 4 kilogram. Okay, it sits on a frictionless 30-degree inclined plane. Our angle of inclination is 30 degree. All right, it is connected by a light string over a pulley to a 6 kilogram angle mass. So the first mass is this. The second mass, what is the angle mass? We are told is what? 6 what? Kilogram. This is the angle mass, right? The angle mass. All right. Okay, then calculate the acceleration of the body. We now have to take G equals to 10 meter per second squared. We also find the acceleration of the body. Find the acceleration of the body. Okay, solution to this is that we already know the diagram, right? For this kind of question, the diagram is like this. We have our mass here. The first mass is 4 kilogram. This first mass is connected over a pulley. So another mass, another angle mass, which is what? About 6 kilogram, right? The weight of this mass is acting downward, which is M2G. This is our M2. This is our what? M1. The angle of inclination here is what? Is 30 degree. So we also find, then we have the weight here, the weight or the weight of this body or the force acting downward, which is what? M1G sine what? Theta. Okay, then we also find acceleration of the system. This is very simple. Recall that we say that acceleration of the system, right, is equals to, is best we say is mg2, right, minus m1g, right, m1g sine theta, all divided by m1 plus what? Plus m2. I guess this is the formula we derived in the first expression. Our formula says what? M2g minus m1g sine theta, all divided by what? M1 plus m2. Don't forget that because we have a smooth surface, so the only force acting on mass 1 is what? M1g sine theta. Okay, so yeah, I think something is common. Our A becomes, between these two expressions, I guess our G is common. So we can say that here becomes M2 minus M1 sine theta, all divided by M1 plus what? M2. So here we're going to have our acceleration to be, we are told that G is 10 meter per second squared. It becomes what? 10 times. Our M2 is 6 kilogram. We have 6 kilogram minus our M1 is 4. We have 4 sine 30, all divided by M1 is 4 plus 6. M2 is 6. So our acceleration then becomes 10 minus, 10 times. Here we have 6 minus 4 times. Sine 30 is about 0.5, right? About 0.5, all divided by 4 plus 6 is about 10. From here, 10 can cancel 10 from here, right? So if that should occur, that implies that acceleration of the body then becomes what? We are left with what here? 6 minus 4 times 0.5 is 2. So what is 6 minus 2? The answer is 4 meter per second squared. This is very simple. All we just need to know is just the formula, then we can be able to solve this problem. The next question I say that, I hope you guys are following, right? Hope you guys are following. Hope you are getting it. Hope you are getting it. If you are following, say I'm following. And let's continue. The next question says, that find the tension. We have calculated the acceleration of the body of the system. Then the question says that also find the tension in the strings. Find the tension, which is our T, right? In the strings. Don't forget that we analyze the force here in the first time in our force explanation. When I explain this, we analyze the force that the weight of this body is acting down, tension is acting up, right? Then tension is acting toward the direction as well. We have our tension. The same tension experienced here is the same tension experienced here. I can just resolve the force here, the vertical force along the inclined plane. So we say that sum of all these forces, right, is simply equals to what? The direction of motion is this way. Motion is this way. That means we have m2g minus what? Minus t equals to what? m2 times what? Acceleration. Even if you resolve this and use the same formula here, if I'm to resolve this, there will be t minus m1g sin theta equals to what? m1a. I will get the same answer because the same tension here is experienced here. But I have to use this short form so that we can just finish up this and move to the next question, move to the next agenda, right? So let's go. So here we have, let's analyze, let's find our tension. Then to find the tension, I have to make my T to stand alone as the subject of the formula, right? So let's move on. That will give us what here? It simply means here minus T equals to M2A, right? When you move this to the other side, it becomes what? Minus M2 what? G. So let's put in our figure. So the next is to divide both sides by minus 1. Minus 1, right? By minus 1 by minus 1. Here become minus cancel minus, we are left with capital T, which represents our tension, equals to minus M2A plus M2G. I hope you guys understand what is happening here. When you divide M2A by minus 1, we have minus M2A. When you divide minus M2G by minus 1, we have plus M2G. So I can write this as M2G minus M2A, right? So from here, it simply implies that our tensional force is, okay, let's take what we can do here again and see. What is common here is actually M2, right? M2 in bracket. We have G minus A. Then our tension becomes our M2. The second mass is what again? What's our second mass? Second mass is 6 kilogram, right? So we have 6 times our gravity is taken as 10 minus what's our acceleration? We calculated this as, I guess, 4 meter per second. We have A as 4 meter per second squared, right? So minus 4. And that will give us what here? 6 times, what is 10 minus 4, which is what? 6, right? Then our tensional force, what? 6 times 6, tensional force becomes what? 36 what? Newton. Okay, this is how we can solve this kind of problem. Now let's move down to something else entirely so we can achieve so much today. Please, if you are following, just say I am following. If you are following, please indicate that you are following. All right, I want us to look at 2024 Physics 101 past question. Although we started solving some problems today at the tutorial college. Then I'm going to continue from where we stopped. Then if there is time, I will have to revisit the previous ones we have learned. All right. So please let's continue. I hope you guys are following. Take every class here serious. Please take every class here serious. All right. Take every class here serious. Please, if you have not shared the group link, if you have not shared this link, rather, please share to your platform. 2 minutes, just 2 minutes, then we'll continue. Please share. If you have shared the link, say I've shared the link. Please forward the link, forward the link, forward the link, forward the link so we can continue. Forward the link, forward the link. I want us to connect as many we can connect to this live class. Please forward the link now, please. I'm still waiting to hear from you. If you have forwarded the link, please forward. Let's keep on sending the link. Let's keep on sending the link. Let's keep on forwarding. All right, guys. So let's continue. Let's solve into past question. Today we have been able to see question 1. That's why do we need to establish a system of standard in physical measurements to ensure accuracy, to ensure consistency, right, of results and all that. Then we have seen question 1b. Like I said, I'm going to revisit them again, but I just want to continue from where we stopped so we can move forward. Now I want us to look at this question number 4. The question is under Newton's laws of motion. Question says the engine of an aircraft which is about to take off a constant force which accelerates the aircraft from rest to a speed of 200 km per hour in 30 seconds. If the mass of the aircraft is 5 times 10 raised to the power of 5 kilograms, calculate the constant force of the engine. This is practically Newton's laws of motion. Sir Isaac Newton gave 3 fundamental laws, right? The first law is called the law of inertia. The second law is called the law of acceleration. The third law is called the law of action and reaction. We know what the first law states, right? That every object will continue in their state of rest or of uniform motion unless acted upon by an external force. That's called the first law, the law of inertia. And the second law states that the rate of change of momentum of a body is proportional to the applied force, right? That takes place on the body. The rate of change of momentum is that proportional to the applied force, right? Then from there, we saw that F equals to momentum divided by what? Time, or change in momentum divided by time. Okay. Then the third law is the law of action and reaction that says to every action there's always an equal and opposite reaction. The action and reaction are equal and opposite. Then the second law and the first law took us to another level where we talked about collision and all that. Okay, but let's look at this question here we have with us. Then we'll go into something else entirely. The engine of an aircraft. Let me clean this board. Please, if you have not shared, let's keep on sharing. There's no need of us coming online and we did not share the group link. I know some of us, we got the group link through some platforms. Maybe someone shared to your platform and you're able to join and all that. And some of you came to this platform because I shared the link. So please do me a favor, share the group link to as many that we can have access to. Just share, just share. Keep on sharing, please. Okay, this is very much important than this class because this class will still be on the YouTube. You can always come back and watch, but we just want people to connect. Let's connect as many as we can. Even those, not only those in the IMSU, maybe those of your friends who are in other universities, UNIBEN, UNIZIC, on APSU, and the rest, and all that. Even those anywhere they are, as long as they are offering physics. This is the general concept. It's general. Every university are offering physics 101. I hope you guys are aware. So please let's share. Let's reach out to others so we can also have other people in this platform. The question says that the engine of an aircraft, the engine of an aircraft, right? The engine of an aircraft, sorry, the engine of an aircraft which is about to take off maintain a constant force which accelerates the aircraft from rest to a speed of 200 km per hour. From rest, meaning our initial speed is 0 meter per second. When the body accelerates from rest, that means the initial speed is what? 0 meter per second. Then say from rest to a speed, meaning our final speed is given as 200 kilometer per what? Per hour, right? In 30 seconds. Our time is 30 seconds. Then we are now asked to, if the mass of the aircraft is 5 kilograms, if the mass of the aircraft is 5 times 10 raised to power what? 5 kilograms. If the mass is this, calculate the constant force. The constant what? Force. This is particularly Newton's laws of motion. Okay? We can start by saying that force is equal to what? NA. Right? Then we can also start by saying that A is equal to what? V minus U over what? Over T. We can either start by finding our acceleration force, then any value you have acceleration, we multiply that value with what? With mass. Or we can just bring that the full formula for force for the second law of motion. We just say recall that force is equal to what? Change in momentum, right? Over what? Over time. Over time. I can just apply this direct and get my direct answer. So that means our force is equal to the mass of the body is about 5. Okay, but before we solve, we need to do something to our speed. Our speed is in kilometer per hour, but speed should be in meter per 1 second. So I think we have to convert this first. We have to convert this. Let's convert this. To convert this will give us what? 200 times 1000 divided by 60 times what? 60. 200 times 1000 divided by 60 times 60. Let me explain this. If I have 200 kilometer per hour, right? This is same as what? 200 kilometer divided by what? 1 hour, right? 1 hour. I hope you're aware. So I'll convert this kilometer to meter, meaning 200 times 1000. I've converted this to meter. Then to convert from hour to second, the 60 times what? 60. Are you guys following? So by the time we convert, let's divide and know what we have at the end of the day. Let's divide and know what we have at the end of the day. Okay, let's check. Where's my calculator? When we divide that, that will be about 55.56, right? About 55.56 meter per watt per second. Please always ensure you use the appropriate SI units. If not, you will end up solving. At the end of the day, you fail it. Work done becomes equal to 0. All right. So convert. This is already in the appropriate unit. This is already in the appropriate unit. Time is in second. Mass is in kilogram. But speed must be in meter per second. That was the reason why we have to convert. Okay. Let's take again. We said we multiply 200 by 1000, right? Okay, then we divided by the result divided by 3600. That will give us 55.5555, which is about 56 meters per second. Thank you. So let's move on. Now we can now apply our formula, right? Here becomes our mass is given as 5 times 10 raised to power what? 5. Multiply with our final speed is what now? 55.5, right? Minus initial speed is 0. All divided by our time is 30 seconds. Is 30 seconds. So our force becomes what? Let's evaluate together and see what we are going to achieve. Here will give us 5 times 10 raised to power what? 5 multiply with 55.5 divided by 30. So let's go times 5. This will give us about force equals 277.78 all divided by times. This is 5 times 5.5, then times 10 raised to power 5, all divided by 30. So divide this result by 30. That will give us about our force equals to 9.26 times 10 raised to power 5 Newton. So this is the force we are looking for. 5.26 times 10 raised to power 5 Newton. Okay. All right. So this is our answer here and all that. But though we can leave the answer this way, but you can still convert if you want to convert, or if you want to put this in the not maybe to remove it from the standard form, you know what to do, right? So I will move my points 1, 2, 3, 4, 5. Then I'll bring out how many zeros at the end of the day. Okay. All right, guys. So let's proceed. The next question here, the B part. The B part says that. Let's look at the B part. Next question. Question number 4B. Of mass 500 kilogram. Of mass 500 kilogram. Please, if you are following, indicate that you are following. Indicate that you are following. Indicate that you are following. A man of mass 500 kilogram. A man of mass 500 kilogram. A man of mass 500 kilogram. The mass of the man. The mass of the man is 500 kilogram. Okay, this is the appropriate SI unit. Okay, stands in a lift. Stands in a lift. What is the reaction from the floor of the lift if the lift moves upward? What is the reaction from the floor of the lift if the lift moves upward with an acceleration of acceleration of 0.6 meter per second squared? All right. Number 2, if the lifts move downward, with an acceleration of 0.4. Okay, the first question is, what is the reaction, right? What is the reaction? Okay, what is the reaction from the floor of the lift if acceleration is about 0.6, right, meter per second square? That's the first one. Number 2 says, what is the reaction if acceleration is about 0.4 meter per second square, right? Okay, are you there? Okay, I think this question is not clear. It's very blur. I'm trying to get the answer. I'm so sorry, guys. Let me repeat again. A man of mass 500 kilograms stands in a lift. What is the reaction from the floor of the lift if the lift moves upward? Okay, the first one. What is the reaction of the lift if the lift moves what? Upward, Abi? With an acceleration of what? If the lift moves upward. This is for upward, right? This is for upward. Then so the second one, what is the reaction if the lift moves what? Downward, right? The lifts move downward, okay, with an acceleration of 0.4 meter per second square. Then I says, what condition in the lift will make the man weightless? What condition? What condition will make the what? The man weightless? Weightless. Okay, let's look at this now. Let me analyze this very briefly so we can understand. Now listen, let me analyze this. A man stands in a lift. There's a topic under which is under Newton's laws of motion. We call it lift and elevator. You know what is a lift? A lift is mostly used to lift people, to take people from one point to another. Let's say from a lower floor to a higher floor. Mostly used in banks, right? Okay, to move it from the ground floor to, let's say, to the next story building or whatsoever is is a is a device that carries people, okay, to their point of destination. If they are climbing, instead of them following through the normal staircase, you can take a lift, right? Now, the principle of a lift is that if I have a lift, let's say I have a lift here, this is a lift, okay? I'm just assuming, okay, a diagram like this to represent a lift. Now, if I have a lift and I have a body kept inside a lift, the weight of this body, you are this body. This is a person standing inside the lift. The weight of this body is always acting what? Downward, which is what? Mg, right? There's a force acting upward, which is called what? The normal reaction. Normal reaction. Normal reaction. We also use M to represent it. Now, we call this normal reaction under a lift the apparent weight. The what? Apparent weight. This is also called the apparent weight. Apparent weight of the body. Then W, this is called the real weight of the body. The real weight of the body. Meaning I can measure my real weight by multiplying my mass times gravity. Your real weight is always acting downward, which is mg. Then the normal reaction, which is the apparent weight, which is the reading on the scale of the lift. When it wants to stand in the lift takes a reading. The lift can measure your reading. Okay, there's a scale where you can measure the value of the individual that stands in the lift as the lift is moving up or the lift is moving down. Either. So the measurement from from the scale of the lift is called what? The apparent weight, not your real weight. Your real weight is that weight, the force that acts downward. In our previous class, I was able to differentiate between what we call the weight of the body and the normal reaction or the apparent weight, right? Normal reaction, which is the reading on the scale of the what lift, is that force the floor of the lift or of the elevator is exerting on the body. Either that is the force the floor of the lift is exerting on the body, while the weight of the body is the force the body is exerting on the floor of the lift. Either. Now, if you look at this now, a lift can either move upward or can also move what? Downward. Just take note that all throughout lift system or in a lift system rather, normal reaction is always acting upward. Weight is always acting downward. So whenever the lift is going upward, that means normal reaction is acting in the same direction of the lift. So it becomes what? Positive. Don't forget that said any force that acts in the direction of motion is taken as positive because that force is doing a positive work. So it means that when a lift is ascending or is going upward, the normal reaction is taken as positive because normal reaction is going in the same direction of the lift. Okay. Now, when the lift is going downward, it simply means that the weight of the body will be taken as well positive. Let me repeat again. When the lift is ascending, it's going upward, normal reaction is positive. The weight of the body becomes what? Negative. But when the lift is descending, is coming down with an acceleration, it simply means that normal reaction is negative, but the weight of the body is positive. Now, take note of this. Take note before we solve. Note that when a lift ascend or move upward with an acceleration, the sum of all forces is ascending. Normal reaction, I can just say that the sum of all forces is what? Normal reaction minus the weight of the body is equals to what? Ma. Is equals to Ma. Why? Because the lift is ascending. In your free body diagram, normal reaction is acting in the direction of motion. So it's taken as this. So that my normal reaction is simply Ma plus what? W. But don't forget that W represents what? Mass times gravity. So normal reaction is equals to what? Ma plus what? Mg. So from this, our R is equals to what is common here is mass, which is what? A plus what? G. So this is how to find the reading on the machine or on the lift or elevator when the elevator is ascending or is moving upward with an acceleration. Are you there? Or is accelerating upward. Are you following somebody? So that's why if you look at this here, our R becomes what? Mg, Ma plus what? Plus G. Are you there? When the lift is ascending, so normal reaction minus the weight is equals to what? Ma. But what happens when the lift is descending? When the lift is descending with when the lift descends with a constant acceleration, when the lift descend, don't forget that the weight is mg, right? The weight is mg. When it's descending, that means the only force that is moving in the direction of motion is simply the weight. So the sum of all these forces becomes what? That will give us our weight minus, right? Minus what? R, all equals to what here? Mg. So from here we can say that our weight is mg minus R equals to what? Mg, right? For the body descending. So from here we can say that. Let's finish up this. That will give us what? We're going to have here to be minus R equals to what? Mg minus what? So equals to Ma, right? Equals to Ma. So here minus R equals to what? Ma, right? Ma minus what? Mg. So from here we can say that our R rather, I can divide both sides by R, right? So we have R equals to what? Minus Ma plus what? Mg. Then we can factorize this to be, here becomes Mg minus Ma. Okay, I just interchange their position. Normal reaction then becomes mass is common, in bracket we have G minus A. G minus A. So we can see that when a lift is descending or is coming down with an acceleration, the normal reaction equals mass G minus what? A. Now the next question, the next one I want us to look at is this. The next is when a lift is ascending or is moving upward with a constant, with a constant velocity. With a constant velocity. When a lift, whenever you hear the word constant velocity, that means there is no acceleration. That means my acceleration is equal to what? Zero. Huh? Zero what? 0 meter per what? Second. It's meaning that the body is not accelerating at constant what velocity. But when the lift is ascending, we say sum of all forces, right? Equals to what? R minus what? Weight equals to what? Ma. When it's ascending upward, right? Good. So that means there becomes R minus what? Our weight is mg equals to mass times 0. Our value of acceleration or vertical acceleration is simply 0, right? So normal reaction is minus mg equals to what? 0. By the time we move this minus mg to the other side, that will give us R equals to what? Mg. So what are we seeing here? That when a lift is ascending with a constant velocity, the normal reaction, the reading on the machine, okay, which is the R equals what? Mg, meaning the apparent weight of the body is equals to what? The real weight. The apparent weight equals to what? Real weight. When the lift moves upward with a constant velocity, apparent weight, the reading, the scale on the machine is equals to what? Mass times what? Gravity. The same will also occur when a lift is descending with a constant velocity. The same will also occur. Let me show up here. When a lift is descending with a constant velocity, when a lift is descending with a constant velocity, the sum of all forces when a lift descends at constant what? At constant velocity, okay, is descending, all right? So it means that the sum of all forces becomes what? The weight of the body minus what? Normal reaction, which is equals to what? Ma, right? Okay. From there, we can just solve for that. So our weight is mg minus r, right? All equal to what? Mass times 0. Don't forget that at constant velocity, acceleration A, vertical acceleration equals to what? 0. All right. So from here, we can say that mg is minus r is equals to what? 0. By the time we move this to the other side, we have minus r is equals to minus what? Mg. Minus cancel minus. So normal reaction is T equals to what? Mg. Now you can see that whether it's descending or ascending, as well as it's ascending or descending with a constant velocity, the apparent weight of the body is equal to the real weight, which is equals to what? Mg. Please take note. Now, what about the last case? That there's a case that says that when a lift falls freely under gravity, when a lift falls freely under gravity, when that occurs, that means the lift it becomes what? Weightless. The lift becomes weightless. They might ask you in the exam, at what's the condition for a lift to be weightless? Number one is that the lift must have to fall freely under gravity. Number two is that the vertical acceleration of the lift, okay, is equal to gravity. Acceleration due to what? Gravity. When the vertical acceleration equals what? The gravity, which is g, the lift must have to fall freely. Let me show us what I mean by that. Very important. And I'm going to show us something very important. I'll come back to this question, all right, so that we can. I mistakenly claimed it, but let us look at it together. When a lift falls freely, falls freely, under gravity, what happens there is that vertical acceleration equals to what? Acceleration due to gravity. When it's falling, the same condition, sum of all forces, don't forget it's falling. So that means weight takes the positive value, right? Minus what? R takes the negative value. All equals to what? Ma. All equals to Ma, right? So let's look at what we are going to argue. Our weight is mg minus R, all equals to what? MA. So by the time we move this to the other side, it becomes minus R equals to what? MA minus what? MG. We have already done it before. I'm just repeating. We want to show us something. So from here, I can see that R is equals to what? MG minus what? MA. Okay, so R is then equals to what? Mass is common. Here we have G minus A. Exactly. So since we say that vertical acceleration equals to what? Acceleration due to gravity. That means A and G are the same. This is our vertical acceleration. Hope you are aware. This is our vertical what? Acceleration. Right? Okay. Every time you see A under lift, it simply means what? Vertical acceleration, because the lift is only accelerating vertically, not horizontally. So the only acceleration we can capture in a lift is simply the vertical acceleration. So here we are saying from here, since we are saying that vertical acceleration, since vertical acceleration is equals to what? Gravity. That implies that R is equals to mass times what? 0. I hope you know it's 0, because if AY is G, what will it be? G minus G. That will give us what? 0. Right? That will give us 0. Even if I'm saying that let G be AY, what is AY minus AY? Is still 0. So since AY is equals to G, when you subtract both of them, since they are the same, the result will be what? Will be 0. So 0 times mass then will give us what? R equals to what? 0. Now, the condition, I've already answered the next question, which is question, I think, 4C on what? The condition for a body to be weightless, for a lift to be weightless, or, okay, the condition for a lift to be weightless. Number one condition is the body must fall what? Must fall freely under what? Under gravity. The body must fall freely under gravity. Number two is that vertical acceleration must be equal to what? Acceleration due to what? Gravity. Number three is that the reaction, the normal reaction or the apparent weight of the body. If you look at this, mass times 0 will give us 0. Must be equal to what? 0. These are the three major conditions for a body to be weightless, or for a lift to be weightless, right? Okay, now let's solve the problem we have. Please, if you are following, please. If you are following, please indicate that you are following. Indicate that you are following. Someone says it's confusing. What is confusing? Please indicate so that we can know how we can help you. What is confusing? What is confusing? Let's know how we can help you. What is confusing there? Someone is saying, sir, the production practical. What does that mean? Please explain. The production practical. Please explain. I don't understand what the guy mean by that. Crystal Bear, are you following? Chinanza, are you following? Hopmechi, are you following? Honor is confusing. What is confusing? Adeze is confusing. What I say, go ahead, go ahead. Yes, sir, continue. What is confusing? Have I cleared you? Have I cleared you? If I cleared you, just say yes, you have been cleared. So we can know how we can proceed. Now let's solve a problem. I think by the time we solve a problem, we okay, you just call me. Sorry. Later you can just go through the video. For those just coming, you can go through the video. All right. I will make the videos will still be in the YouTube channel. Can always go back anytime and revisit them. Now let's solve now. Now we know the formulas, right? We have known the formulas. The next is to start solving. the next is to start solving. The question says that a man of mass 500 kilogram, the mass of the man is given as 500 kilogram, right? Okay. Stands in a lift. What is the reaction from the floor of the lift if the lift moves upward with an acceleration of 0.6 meter per second? What is the reaction? What is the reaction if the lift moves at what? At A equals 0.6 meter per second. What is the reaction if the lift moves upward, right? If the lift moves what? Upward at A equals what? 0.6 meter per second. Number 2 says, what is the reaction if the lift moves downward? At acceleration 0.4 meter per second squared. Number 3 says, what condition in the lift will make the man weightless? What condition in the lift? What condition in the lift will make the man weightless? Okay, I'm not going to solve this again. I already list the conditions. Abi, condition for the man to be weightless. Please go through the class again. For those of you who just came, I've explained this already. Condition for the man to be weightless that, okay, the lift must have to fall freely under what? Gravity. Number 2 is that vertical acceleration, which is AY, must be equal to what? Acceleration due to gravity. Number 3 is that the apparent weight of the body must be equal to what? 0. The apparent weight is 0. So I've already answered this question. So let's go into the first and second. Now the solution for the first one says, what is the reaction, right? If the lift moves upward, meaning that R minus what? Mg equals to what? Ma. Don't forget, okay? If the lift moves upward, meaning that the normal reaction is this way, the weight is this way, right? So that means our normal reaction is positive minus Mg equals to what? Ma. Sum of all forces is this. So the reaction becomes what? Ma plus what? Mg. And that will give us mass A plus G. So let's put in our value. Our normal reaction becomes, our mass here is given as 500. Okay, 500, yes. 500 times our vertical acceleration is 0.6. Okay, plus, let's take what the value of G is given as. The value of G is given as. I'm coming. So we can just, let's solve with the accurate value of G. If G there is 9.8, I think G should be 9.81. But let me just verify. So we can solve with the accurate value. Are we there now? Okay. Okay, our G there is taken at 9.8. 9.8. Okay, so what we do now is to add up, right? When the lift moves up, we have to add up. So let's add up. We're going to have here to be normal reaction equals 500 times 0.6 plus 9.8 is about 10.4. About 10.4, right? So 10.4 times 500, normal reaction becomes what? Becomes 5,200 what? Newton. Okay, the major thing is just to know the formula to use. Then we can be able to solve this problem. I hope you guys are following. 0.6 plus 9.8. Let me verify again. 0.6 plus 0.6 plus 9.8. Okay, that is about 10.4 then times 500. This is about 5,200 Newton. Now the next is what is the reaction if the lips moves downward, right? If the lips moves downward, if the lips moves downward, what would be the reaction if the lips downward? All right, so let's finish up this. So this will give us for downward, it means that our weight minus normal reaction is equals to what? MA, right? So we have minus R is equals to MA minus W. So here becomes what? Our normal reaction becomes the weight minus MA. So here we can say that R equals to mg minus what? MA. Then R is equals to mass in brackets G minus A. I'm just repeating this for the sake of those who just joined us just now. So our value of R becomes the mass of the body there is about the mass of the body there is 500, right? Times our gravity there is 9.8 minus our acceleration is 0.4. What is the reaction if the leaves move downward at when AY is what? 0.4 meter per second square. So please don't use 0.6. The first question is for 0.6, second is for 0.4. So we have 0.4. So here we have a normal reaction to be equals to 500. When you subtract 9.8 minus 0.4, that gives us about 9.4. Yes, 9.4. 9.4. So normal reaction then becomes 500 times 9.4 to give us 4,700. 4,700 Newton. 4,700 Newton. What if this time around the question they now ask another question? What is the normal reaction? What is the reading of the machine when the lift moves at constant, when the lift moves upward or downward at constant what? Velocity. When the lift moves upward or downward at constant velocity. We have seen the proof that whether it's going up or down and the mention at constant velocity means that normal reaction, which is the reading, right? Okay, is equals to what? Mg. All we need to do is to multiply our mass 500 by what? 9.8. Whatsoever we have is our result in what? In Newton, right? Multiply 500 by 9.8, your result, anything you have there is your value in Newton. So this is the normal reaction or the reading of the machine when the lift moves upward or downward with a constant velocity. Now the next question I want us to look at, we have seen condition for weightlessness, right? We have seen that already. Question says that explain the terms impulse. That's question number 4. I guess that's 4C, right? That's 4C. Explain impulse. Explain impulse. This is very simple. Explain. The next question says, explain what? Impulse. Okay, let's take it. Please, if you are following, please indicate that you are following. Hope you guys are following. Hope you are following. Hope you are following. Hope you are following. Hope you are following. Okay, awesome. Someone said she got 5,300, right? Is the value, is it for at constant velocity, or which one are you talking about? Okay, let's look at the next question. Say explain impulse. Explain impulse. Explain impulse. I'm going to show us something, then I will explain us. From Newton's law, second law of motion, from Newton's second law, we note that force is equal to what? Change in momentum over what? Over time, right? Okay. From here, we can cross multiply this, right? We can cross multiply this, cross multiply this. When by the time we cross multiply, force times time will give us what? Ft equals to what? M V minus what? U. Force, the product of force and time is what? Is impulse, which is also equals to change in what? Momentum of a body. So impulse can be defined in two ways. The first is that impulse is the product of force, of average force acting on an object and the time interval during which it acts. It is the product of the average force acting on an object, the product of the average force times time, the product of the average force acting on an object and the time during which it acts, right? Uh-huh. Impulse can also be defined as change in momentum of a body. So if you have to define impulse, I would love just start from here, from this second law of motion, just give them the expression. Then when you define the first one, the product of average force, okay, on the body and the time during which it acts, right? Then impulse is also defined as change in what? Momentum of a body. Okay, and repeat again, impulse simply means product of what? Average force and what? And time, or product of force and time. All right, or from here, mv minus u, impulse is ft, which is the same as I. So ft equals to what? Mv minus u. So force times time is impulse. Impulse can also be defined as for change in momentum of a body, not the rate of change. If you involve the rate of change, that means I'm saying that mv minus u divided by t. So to define impulse, I repeat again, it's the product of average force and time, or it is defined as what? Change in momentum of a body. Change in what? Momentum of a body. Impulse is measured in Newton seconds. Look at this, force is in Newton, time is in seconds, or impulse is also measured in mass is kilogram, while speed is what? Meter per what? Second. So we can either use this to represent what? The unit for impulse. So when you define impulse as the product of force and time, they also define impulse as the change in what? Momentum of a body. Then tell them that that the unit of impulse is either what? Newton second or kilogram meter per second. Meaning 1 Newton second is equivalent to what? 1 kilogram meter per second. Now let's proceed to the next question. The next question, please, if you are following, indicate that you are following. Question number. Please indicate that you are following. Please indicate that you are following. Please indicate that you are following so that we can proceed. Indicate that you are following. Okay. Someone said I use 10 as G. Fine. It's okay. It's okay. That is good. Okay. That was why you have 5,300 Newton. It's okay. It's fine. All right. So let's proceed. Let's proceed. Let's proceed. Let's proceed. Let's proceed. The next question here, question number 5. Define the following as used in oscillation. Define the following terms as used in oscillation. Define the following terms as used in oscillation. Define the following terms as used in what? In oscillation. Let's define them. I will list out all the terms, I will explain them and define. Alright? Okay. Define the following terms as used in oscillation. The first question says frequency. This is very simple. Imagine you coming across this in the exam, which is F. Number 2 is period. Well, this is awesome, which is our capital T. Number 3 is amplitude. 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 All right. This is just the question for number 5. Question 5A. Question 5A. Now the first one is frequency. Frequency simply means the number of what? Oscillation made by a vibrating body per second. The number of oscillation. The number of oscillation. Oscillation made by a vibrating body. By a vibrating body per what? Per second. Frequency is the number of oscillation made by a vibrating body per second. All right. Frequency we know is 1 over what? Period. Is an inverse of what? Of period, right? Frequency is also defined as if angular velocity is 2 pi frequency. That means our F can also be defined as angular velocity divided by what? By 2 pi. Please take note of this. Okay. Frequency is 1 over what? Period. It's also defined as what? Angular velocity divided by what? 2 pi. From the definition of frequency, number of oscillation made per second. So I can say that F is also equal to what? N over what? Over T. Over T, where N represents number of oscillation. Okay, then T represents what? The time. Time for oscillation given. Okay, number of oscillation made per second. That is frequency. Now, period is simply the time taken to complete one oscillation. Period means the time taken to complete one oscillation. So, if frequency is inverse of period, that means period is also inverse of frequency. So, my period here becomes what? Becomes 1 over what? F. All right? Becomes 1 over F. Also, my period here becomes, if I'm saying that F is 1 over T, 1 over T, right? So we can say that the value of our period will be 2 pi over what? Angular what? Velocity. 2 pi over angular velocity. Because angular velocity is actually 2 pi over T, right? Yeah, it's 2 pi over T. So by the time we cross multiply this, WT equals what? 2 pi. So our T becomes what? 2 pi over what? Angular velocity, which is the same thing we did here, right? So period is 1 over F, or period is what? 2 pi over what? Angular velocity. Then if we are saying that frequency is N over T, so what do you think will be the period? Period becomes what? Small t over what? N. T over what? Number of what? Oscillation. But don't forget that frequency is measured in hertz, right? It's measured in hertz. While period is measured in what? In seconds. It's measured in seconds. Don't forget, okay? Don't forget. After defining them, you bring out their formulas. At least these 3 formulas is okay to represent each of these. Either then we can, once we are done defining, we can then bring out the units. Then the next one is called the amplitude. Amplitude means the maximum displacement of a body performing simple harmonic motion. Okay, the maximum displacement of a body. Full stop. The maximum displacement of a body. The maximum displacement of a body. Of a what? Body. Alright? It is measured in what? In meters. Measured in meters. It shows the maximum displacement of a body. Because in a simple harmonic motion, we know where the maximum displacement is. If I have a simple pendulum, okay, a simple pendulum like moves where the box moves to and fro, right? At point A and point B, when the ball moves to this point and return back to and fro. At this point, we have our maximum displacement, right? We have our amplitude. We have what? Amplitude. Other point, we have our displacement, right? Displacement. But at this highest point here, let's say we have point A and point what here? Point B. At point A and point B, the body is maximally is at the maximum. So the placement here is maximum. We have maximum displacement. We have maximum acceleration. But I'm not going into it because I'm focusing on the past question A lot to be said on this. By the time we progress into other years, we'll look at some other aspects of your past question, of some topics rather, in physics. We look at simple harmonic motion. We look at rotational dynamics of the body. We look at a conical pendulum. All right. We look at so many to discuss from now till your exam. Just ensure that you are following. You keep sharing the link and all that. So please let's proceed. Let's proceed. I hope we have gotten this right. Now the next question. Let's try the next question. The next question. Please, if you are following, indicate that you are following. If you are following, indicates that you are following. If you are following, indicates that you are following. Please indicate that you are following so that we can know those who are following. Please indicate that you are following. Indicate that you are following. Okay, someone said I'm following. Please indicate. Indicate. Like some of you are sleeping. If you are not sleeping, please indicate. I hope it's not what I'm thinking. That some of you are sleeping. Please indicate. Wake up, wake up, wake up, wake up. Share the link. Indicate that you are following. I hope they are not sleeping. I hope they are not sleeping. Okay, so let's proceed to the next question. Question number 5B says, a car with mass 400 kilograms. A car with mass 400 kilograms. A car with mass 400. The mass of the car is 400 kilograms. Is powered by an engine delivering a maximum of 45 horsepower. Power is 45 HP. All right, the power is 45 watts HP. At what maximum speed could it go up a 15-degree incline? Our angle of inclination is 15 watts degree. At what maximum speed will it go up? At what maximum speed will it go up? What is the maximum speed that this body will have to go up? Okay, let me check. Oh, we have 9 persons online. Please, if you are following, please indicate that you are following. Indicate that you are following. Indicate that you are following. Please indicate. Let's know those who are online. Let's know those who are online. And let's keep on sharing the group link. 1 more minute. Share the group link. 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 Share. Okay, now let's proceed. Now, here we have a very important question here. Very, very important question here. We are told that the mass of the body is 400 kilograms. The power is what? 45 horsepower. Is that clear? Then the question says that, let me get back to the question so we can proceed. Question number what is it? Forward. Okay. Question number what? A car with a mass of 400. Is that 400? Yeah, 400 kilograms. Right? It's powered by an engine delivering a maximum of 45 horsepower. Right? Okay. At what maximum speed could it go up? We have an incline here. We have an incline, right? At what maximum speed will it go up? If this is the car here, the mass of the car is 400 kilograms. The angle of inclination is 15 degrees. Don't forget. So this body is going up this way, right? This is direction of motion. Direction of motion. Okay. At what maximum speed will it go up? All right. Will it go up, decline? Let me verify again. Neglecting all frictional forces. Neglecting all frictional forces. That means we are dealing with a smooth surface. So that means that if I have a body kept on this kind of diagram, on this system, and the body is going up the incline, it's going up the incline. The only force acting on this body, don't forget that there's always a force that acts downward, which is what? Mg what? Sine what? Sine theta. Mg sine theta. Right there. So it simply means that the only force acting on this body is simply what? The sliding force, Abi? The sliding force, which is mg sine theta. But what do we do first? Power should be in watts, not in horsepower. But I hope you are aware that 1 horsepower is about 746 watts. 1 horsepower is about what? 746 watts. So what do we do first to convert our power to what? To watts? That means I'm going to multiply 45 times 746. And that will give us, let's multiply together and see what we're going to come up with. Let's multiply together. Here we have 45 times 746. This will give us about 3. Our power here is what? Is giving us 33570 watts. Please verify for me. 3357. We are asked to find the maximum speed, right? At which the body will move up the incline. Find the maximum speed at which the body will move up the incline, the maximum speed, right? Okay. Now let's see what we are going to achieve here. Please take for me. Let's take something. I hope 1 horsepower is 746. So when multiply, we have 33,570. Yeah, we are correct. Now listen. Hope you are aware that recall the power is work done over what? Time taken. Work done over time taken. Okay. And also work done is force times what? Distance. Work done is force times distance. Power is work done over time taken. Power is work done over time taken. Then work done is force times what? Displacement or distance. Abi? So that means my power becomes what here? Our work done will be force times what? Distance divided by our speed. Divided by speed. Okay. Force times distance. Sorry. Force times distance rather. Divided by what? Time. Divided by time. Then I hope you are aware that distance over time is equals to what? Speed, or displacement rather. Displacement over time. Force times displacement. Work is force times displacement. Then we have here to be, we have to put the value of this work as force and displacement into the formula for power. Here becomes what? Force and displacement over time. Displacement over time is what? Velocity. Right? Displacement. Velocity is defined as displacement over what? Over time. Exactly. So that means I can replace the whole of this to be power equals force times what? V. Force times V. Force times V. Okay. We are heading somewhere. But recall that the only force acting on the car or on the body or object, or I think that should be car, right? Is simply our Fg. This is what? Our Fg. Although the body is going up, Fg is meant to be negative, right? But I'm going to take the absolute word value because I'm solving for power. Either. So the only force acting on the body as this body moves up or moves along this frictionless surface is simply what? Mg sine theta. So that means my power here becomes what? Our force becomes what? Fg times V. Okay, don't forget that we are saying that P equals what? Work over time. Work is what? Force times displacement. So let me start by saying that the force here is what? Is Fg, right? Here becomes what? Fg times displacement over time from the formula for work. But we say that displacement over time is what? Velocity. So that means I can replace the whole of this. The displacement over time is now replaced as what? V, which is what? Fg times V. But Fg is given as what here? Mass mg sine theta. So here becomes what? mg sine what? Sine theta times our speed. So that means to find the speed, it simply means power divided by mg sine theta. Someone will say this man likes deriving formula. If you don't derive formulas, you might not be able to get your result in physics. So most of the time you have to derive. That's why I take my time to derive. Even for my students who attend physical class, I always love deriving so that you understand how to come in at any point in time. So the formula we're going to use to find the speed at which the car is climbing the incline is simply what? Power divided by mg sine theta. Already we have our power as this, right? We have our mass as 400. Then we have gravity as 9.8. Then we can multiply with sine theta. Our angle is here is what? Is 15 degrees. Now let's solve. Let's solve. So this will give us our speed, our velocity equals to what? Our power is, we have our conversion. 1 horsepower is 746 watts, right? 1 horsepower, 1 HP. We agreed is what? 746 watts, right? Okay, so multiply this with 746. That gives us this. So our power is what? Is 33570 divided by what? Our mass is 400 times. Our gravity is 9.8 times. Then we have sine. Our angle of inclination is 15 degrees, sine 15. So let's punch our calculator to see what we are going to come up with. Let's punch calculator to see what we're going to come up with. So we have 400 times 9.8 sine 15. This will give us our speed equals 33570 divided by, when you multiply this with this, then multiply with sine 15. The result will be about 1014.5. Okay, this will be the result. So by the time we divide this with this, our answer is going to be 33.09 meter per second. So this is the speed at which the car must have to move, okay, must have to climb the inclined plane. So let me check again. I have sine 15 times 400 times 9.8. I'm sorry, pardon me. We have sine 15 times 9.8 times 400. This is about, okay, 1014, okay, 0.57. All right, so let's divide now. 33570 divided by the answer we have. This is about 33 points. You see the same thing? 0.09 the same thing in meter per second. So this is our answer for this question. Okay, please, if you're online, still indicate that you're online. If you're active, indicate that you are active. Please indicate that you are active. Declare that you are active. Indicate that you are active. Someone is asking, what about the applied force? There is no applied force here. We're not giving reference to any applied force. A car is being powered. The car has been powered already. The power is already given as what? As 45 horsepower. We're not pushing the car. If there's an extra force, then we'll have include the force, right? Thank you for that question. That means you are following my class. But in this case here, there is no applied force. The car has been powered already. That's why we needed to use the formula for power as work over our time. Are you there? We still involve power because the car has been given its power to move up the incline. So this is not a case of an applied force. If there's an applied force, that means I have to consider the applied force, the applied force, and the applied force will be given to you. Let's say a car is being pushed, okay, with a force of 20 Newton up the inclined plane. That means that I'm going to use this to solve for the force. I mean, sum of all forces becomes what? F minus what? Fg. Is that clear? So what we do is to find the resultant force, right? So find the resultant force. So that means I have to say F minus Fg equals to Na. Is that clear? But in this case here, we are not looking, they didn't give us apply force, and they can't give you apply force, actually. Apply force, when it's given, it simply means that you will now be asked to find the acceleration of the body, because if there's an apply force and Fg is acting this way, apply force is acting this way, that means that you must be asked to find the acceleration of the body. But this is not the same thing with this. But in this case, we are giving that the body, the car has been powered already. The car has been given a power of 45 horsepower. So the car is moving by itself. Are you there? The car is moving by itself. So this is the speed at which the car is moving. All right. You know, I told you guys something in my previous class. I said there are two things that can make body to move up an inclined plane. One is that if that car has been given a velocity, which is about 3.09. But in this case, the equation was twist. We are asked to find the speed at which the car is moving. Number two is that the car must be applied. There must be an applied force for a car to move up an inclined plane. To find the acceleration of the body, one is that that car must move with a certain velocity. Number two is that the car must be given an applied force. Is that clear? But for this, since the car has been powered, there is no need going through that process. All we don't need to do is to find the only force responsible for the car to climb up the hill. Is just the only force responsible or acting on the body as the car is moving up the hill is just mg sine theta. Is mg sine theta, which is our fg. Okay, that means the work done by that force is simply what? Fg times what? Displacement. What if we also find the work done on the body? From here, work done is Fg times d. All you need to do is to evaluate it by saying that Fg is what? Is given as mg sine theta, and you must be giving your displacement. You must be giving displacement. All right? Okay. You must be giving displacement. That is just how simple this question is. Now, the next question I want us to analyze, take us time, but let's see how we can solve this problem. Hope there's no other further question. Please, if you are following, if you are enjoying this class, just indicate that you are enjoying it. Please, if you are following up, please indicate that you are following. Indicate that you are following. Indicate, so that we can finish up this. Okay, I want us to look at, there's a question here. I'm going to take my time to explain this question. This is the first time IMSU is setting such kind of question. Okay, I'll take my time to explain it. Okay, and this might form the last question we might be looking at tonight. This question is a kind of tricky, but we'll solve it together. Then if you have any further question, you can always ask me. Let me bring out the question for us. That's question number, I guess that should be number, I'm coming, please pardon me. That's question number 5C. 5C. We have seen 5A, right? 5C. So let's exhaust every part of question 5. So the first show that the period of rotation of rotation hmm, of rotation that is T of a conical of a conical, or we call it count, is it a mistake? Conical pendulum. That's a mistake. Conical what? Pendulum is given as T equals 2 pi square root of L cos theta divided by G, where L is the length of the string. Theta is the angle the string makes with the vertical. Theta is the angle the string makes with the vertical. And G is the acceleration due to gravity. Okay, before we solve this, I would like to know your opinion so far on other ones we have solved. I hope everything is clear. Please, I would like to know your opinion right now on the comment section. Please, let's comment. Let me know your opinion. What are your opinions? Is it going well? If it's not going well, let me know. If you're not getting, let me know. Please comment. Please be fast with your comments. Be fast with your comments. Be fast with your comments. If it's going well, please indicate. If it's going well, please indicate that it is going well. Be fast, be fast, be fast, be fast. If you are following, just indicate that you are following, please. Some of you are not indicating, are not even saying anything. I'm not even saying anything. Please say something. Let me know. Please say something. Say something. Say something. Please say something. Say something. If you are following, please indicate that you are following. Please indicate. Okay, it's going well. It's going well. Only two persons said it's going well. What is happening to others? Now, I will draw a diagram here. Then I'll clean it because this will take me a little. This question is kind of lengthy, so it will take me like few minutes to explain this. But I want you guys to understand this because this might be repeated in the exam, and this time around they might just repeat this and give you a problem to solve under this. Now, show that the period of rotation of a conical pendulum is given as this. When you hear the word conical pendulum, it's not simple harmonic. It's not a simple pendulum like you all know. Conical pendulum and simple pendulum are not the same. Simple pendulum, right? Is a kind of pendulum that moves this way. Is that clear? It moves to and what? And fro, right? It moves to and fro. It moves to and fro. When you have a body here tied to a string, the body moves this way. To, fro. That's called a simple pendulum. But when you hear the word conical pendulum, a conical pendulum is a pendulum that moves in a circular pattern. Meaning if I have a mass here and the mass is attached to a string, and that mass is caused to move in a rotational manner, creating like a cone, like a circle. Okay, instead of the body moving this way, the body is moving in a circular pattern, like in a circular pattern. So that is the principle, or we call our conical what? Pendulum. Conical pendulum. All right, it's not same as simple pendulum, but um, let me just show you. Let me draw a diagram to express conical pendulum. Then we can take it off from there. We will now derive some formulas and all that. Then this is the, let's say this the ceiling, and we have sorry we have our mass attached here. We have the length. Okay, this is the length. This is the height of the pendulum. The height is here. This is the height, right? Okay. Then the mass is somewhere here. Don't forget. All right. So now listen. We call this the length of the pendulum of the string. All right. This is the mass here. Okay. Then there's an angle. We are told that so that the period of rotation t of a conical pendulum is given as this, where L is the length of the string, which is our L, abi? Okay. Theta is the angle the string. This is the string here. Is the angle the string makes with the vertical. So there's an angle here, right? Called what here? Theta. So if my angle is right, my direction will be somewhere this way from the angle, from the point here, right? It's coming downward. Right there. So this is my length here. And we also told that the string makes, okay, with the vertical, and G is what? The acceleration due to what? To gravity. So this part, we call this part what? The height. Now, let me draw a diagram to express this. This is our conical pendulum here. Conical pendulum, sorry. Let me express this way. Okay. Now look at this. This is the conical pendulum. This is how the object moves. The mass is here, right? This is the mass here. Don't forget that conical pendulum is not like your simple pendulum. When you have a ball, a ball attached to a string, and that ball, the ball or the object is caused to rotate in a circular pattern. Are you seeing it now? It's circular pattern. There's a force here called what? Centripetal force. Any object that moves in a circular pattern, the force that is responsible for that circular motion is called what? It's called a centripetal force, right? Now take note that, listen, let me show you something. The first thing I need to do is to resolve some forces here. I have to resolve some forces. Now we are told that our angle is here, but don't forget that this is the center of the circle. From the center to this point, right, is called the radius. Don't forget, it's called the radius of the circle. Now listen, I can also generate another angle here, vertically upward. This angle is alternate to this angle. So if my theta here is 30, it's also 30. So the angle here and this angle, they are the same. Just take note, okay, that this angle and this angle, they are the same. Now take note, here we have our ty, here we have our tx. You know, if we are dealing with a string, a string attached to a body, right? There's a force that tends to pull the string, pull the body upward. Let's say I have a string and I have a mass. Okay, this is a string, I have a mass. The weight of this object acts downward. Don't forget. So the tensional force will always act in this direction. Is that it? So for this now, my tension is along this region. It's along here. My tensional force is along the y-axis. Don't forget. And also, if you remember very well, when we talk about motion along horizontal surface, that a body is being dragged right with a rope. Where do we say is our tension? Tension is along this rope. tension is always along a rope or a string, okay, attached to a mass, okay. So my tensional force is also along this. So if you look at this very well, this looks like a right angle triangle. That's why I said we can resolve this force T into two components, which is what? Ts and what? And Ty. Now, if I'm to resolve, I've taught you guys something that in vector resolution, if we are resolving a vector, let's say I'm resolving a vector, I have our tensional force here, the angle theta is here, right? And I have my Ts and what here? Ty. This vector T, capital T, can be resolved into two components, which is what? Ts and Ty. And Ts is same as what? T cos theta. While Ty is what? T sin theta. Why? Because the angle between the tensional force is just along the s-axis. Our theta is along the s-axis, right? When the angle of inclination is along the s-axis, or when the tensional force makes angle theta along the s-axis, so that means our Ts must be T cos theta. While Ty must be what? T sin theta. Now, what about if this angle is not here, and that angle is along the y-axis? So that means the reverse becomes the case. Our Ty, our Ts here, Ts will then be what now? T sin theta. While Ty will then be what? T cos what? Cos theta. Anytime the angle of inclination is along the vertical, we can resolve that tensional force on the y-axis as T cos theta, while Ts as what? T sin theta. So we are told that theta is the angle the string makes with the what? The vertical. This is very important. Theta is the angle the string makes with the vertical. So that means we can resolve. We agree that the tensional force is along this region because this is like where the mass is. The mass is here. So tension is acting on this body. Tensional force is here. Is our T. We agreed, right? Don't forget. So we can now resolve this tensional force, T, in both vertical and what? Horizontal, right? Vertical means what here? Ty. What's horizontal? Ts. Whereas our theta is here. So whenever the angle of inclination is along the vertical axis, what do we say will happen if it's here? Our Ty becomes what? T cos theta. Ts becomes T sin theta. So since the angle of inclination is simply along the y-axis, so by vector resolution or resolving, I can say resolving tension T. Our Ts is going to give us T sin what? Theta. Okay? While Ty is going to give us T cos what? Theta. I think I've explained this before. I've explained this several times. I even explained this now. Because our theta is along the y-axis, Ts is what? T sin theta. Ty is what? T cos theta. Right? Now, the next thing is to analyze the system. All right. Please, if you are following, indicate that you are following. Indicate that you are following. We have 8 persons online. Indicate. Okay, awesome. So it's about that inclined plane. Because someone is asking the question. Okay, I totally understand, sir. That is good. I love that. Another person is asking, okay, it's going where? Okay, that is good. Okay. That is awesome. All right. That is awesome. Now, listen. I want us to analyze the forces. Analyzing the forces. The forces. The forces, which is our tension, right? Look at this. For vertical. We can analyze this. Look at this. If we have a string attached to a body, and we say for conical pendulum, the body is moving in a circular path. Exactly. If the body is moving in a circular path, that means the body does not have any vertical acceleration. The body is not accelerating upward, right? The body is only moving with a constant velocity along what the horizontal surface, right? Along the horizontal. So as the body is rotating, the body is only rotating along the x-axis. Is that clear, somebody? The body is not coming up. So if the body is not come to analyze the vertical forces, I'm going to say that vertical acceleration is equals to what? 0, right? Because the body is not accelerating, the body is only moving along the horizontal axis. So if you look at this body, look at this, let me explain something. The body is kept here, right? The body is kept here. This is the mass of the body. Is that clear? Every object, if I have a mass here, I have a body kept here, and I have a mass here. The mass is m. There's the mass will always exert its weight downward. The weight of this mass is simply what? Mg. Don't forget. So I can extend this way. I can extend this downward. That my mass is what here? Is mg. Don't forget that our mass is mg. Okay? So this is the mass here. The mass is exerting its own weight vertically or downward. So because the body is not accelerating, so the sum of all the upward forces must be equal to the downward forces. The upward force we have, look at this line, this way. After resolving this, what do we have? We have Ty. Ty is equals to what? Mg. Let me repeat again. Remember when we talked about motion along an inclined plane? Whenever the value of acceleration is 0, meaning the body is moving with a constant velocity. That implies that what is the implication? It means that two forces are equal. Like, for example, we say that when the applied force is equal to the static frictional force, the body will just begin to move, right? When the applied force is not greater than the static frictional force, the body will start moving. At that moment, the body will now lose static frictional force and gain what? Kinetic what? Frictional force. So as the body is moving, the body only acquires what? Kinetic frictional force. And I stated from I said, when the kinetic frictional force acquired by the body is not equals to the applied force, what happens is that the body will now move with a constant velocity, right? At that point, the body is not accelerating. So whenever a body is not accelerating, that means two forces balances each other. So for this now, our Ty, the force acting vertically upward, must be equal to what? Mg, because the body is only moving horizontally. So there's no vertical acceleration. So I can say that there becomes what? Our Ty equals to what? Our Mg. And what we say our Ty? Ty, we define Ty as what? T cos what? T cos theta, which is equals to what? Mg. Let's call this equation what? Equation 1. Equation 1. Now, can I clean this part? Of course. Let me clean. So don't forget that our aim is to find this, to express T as this, right? That's our aim of this class, is to prove that our T is equals to that. Okay, I just pray that I've not learned something important here. Okay, now let's move. Let's look at this. Look at this now. The body is moving in a circular path along the x-axis. Now, there's a force along the x-axis that is supporting the circular motion of the body along the x-axis. That means that, don't forget that when a body is moving along the circular path, there's a force, okay, exhibited by that body, which is called the what? Centripetal force, the force that causes the body to move in a circular path. But this force is being supported by Ts, because we resolve this T as Ty and what? Ts. So that means what is causing this body to move horizontally is what? Is Ts, not Ty, because the body is not moving vertically. There's no vertical acceleration. So that means the only responsible or important acceleration here is simply what? Horizontal. And also the only important force here is what? horizontal force. That means that the only force responsible for the movement of this body is Ts. That means, and also that Ts is supporting the what do you call the centripetal force. So centripetal force is that inward force that causes a body to move along a circular path. But this force here, which is called the centripetal force, is being supported by what? The our Ts, right? So I'll come here and say it horizontal, horizontal. For horizontal force, this will give us what? Let's go. So it means that my Ts is equal to Fc, right? Ts is equal to what? Fc. Ts is equal to Fc. I can write and say that the centripetal force, okay, is supported, okay, is supported by the tensional force by Ts, okay, is supported by Tx. So what we say is our Ts. Ts is what? Is T cos theta equals to Fx. Centripetal force is always given as Fc, right? Equals to what? Mv square over what? R. Mv square over R. So that means that my T cos theta equals to what? Equals to Mv square over R. Let's call this equation 2. This is our equation 1, right? So what we do next is to so our Tx, oh, I'm sorry, Ts is T sine theta. I'm making a mistake here. Our Ts we have resolved because the angle of inclination is along the y-axis. So Ts is T sine theta, which is equal to what? Mv squared divided by what? R. So the next is to divide equation 2 by what? Equation 1. We say divide equation 2 by equation 1. I will divide T sine theta with what? T cos theta all equals to, I will then divide my mv squared over r divided by mg. I repeat again, I'm dividing equation 2 by equation 1. Here we have t sine theta over t cos theta. Then we have mv squared over r divided by what? Mg. So this way our t can go with t. Here we are left to what? Sine what? Sine theta over what? Cos theta equals to m. Let's analyze this together. Mv squared over r times 1 over what? Mg. From here, mass can cancel mass, right? We are left to what? Sine theta over what? Cos theta equals to v squared over rg. Let's call this equation 3. We are heading somewhere. Now I can now clean this part. Okay, please go through this. If you are writing, please be fast. And if you are following, please indicate that you are following. Please indicate that you are following. Please indicate that you are following. Indicate that you are following. All right. Indicate that you are following. If you are following, please indicate that you are following. Please indicate that you are following. Okay. Someone said following. So let's proceed. Now I can clean this diagram now because we are heading somewhere. We're almost done, actually. We're almost done with it. Okay. Now, here we have velocity, right? There's a relation between linear velocity and angular velocity. For those of you who attended my class under rotational dynamics, I say that they have a relationship that says that recall, right? Recall that V equals to what? Angular velocity times R. This is a very common formula in physics under rotational dynamics or under oscillation, right? Circular oscillation or circular motion. Okay, that V equals to what? Angular velocity times what? Times R. Also recall The angular velocity equals to what? 2 pi divided by what? T. I hope you are aware of this. 2 pi divided by T. Why am I going through this process? Because we have to find the period of oscillation. So I have to look for a means to bring in our period. From here, V equals to WR, right? Because already we have V square over RG. So we have to bring out V as well WR, where W is what? 2 pi over T. So that means that implies that our speed here becomes what? 2 pi R over what? T. This T here is no longer tension, it's now period of oscillation we are looking for. I hope you are following, guys. Now the next is to put the value. Recall that sine theta over cos theta is equals to, from here, okay? Or we can just say put, let's call this equation 4. Equation 4. Then we can say put equation 4 into equation 3, right? Into equation 3, meaning anywhere we see V square, we can replace V square with what? With 2 pi R over what? Over T, right? We can replace that. Now let's see what we're going to achieve here. So we have sine theta over cos theta is equal to, sine theta over cos theta is equal to, our V square is actually 2 pi R over T, all squared, right? All squared. Okay. 2 pi R over T all squared, then divided by RG. Divided by what? RG. Okay. Divided by RG. Now listen, let's finish up this. So we have sine theta over what? Cos theta. Although I can, from here, I can even use sine theta over cos theta to replace what? Tan theta, right? That is tan theta. The ratio of sine over cos is tan, right? But I'm just working because the formula has cosine, so I have to maintain some things there. By the end of the day, some things we cancel out and we'll see the results. So if I have this 2 pi r all squared, it give us what here? 4. 2 squared is what? 4. Pi squared is what? Is pi squared, right? Pi squared is pi squared. Okay, r squared is what? Is still r squared divided by what? T squared. T squared will give us T squared all times 1 over what? RG, right? One of these R here, we cancel what? One of these R. So we are left to what here? Sine theta over what? Cos theta, all equals to 4 pi squared R divided by, we are left with what here? 1G. So T squared times G will give us what? G T squared, or T squared G, right? T squared what? G. T squared G. Let's call this equation 5 now. Equation 5. Now the next is to evaluate further. I hope I can clean here. Please write. If you're writing, please write. And if you are following, please indicate that you are following. If you are following, please indicate that you are following. Please indicate that you are following. Thank you. If you are following, please indicate that you are following. I hope it's going well. Indicate, 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 indicate. This is what IMSU gave last year. This is what they are expecting students to solve in the exam. So please, at the end of the day, make sure you master the procedures and everything. Make sure you go through the classes and write down your notes. You can always go back to this video and study it again. Keep on pausing and play, pause and play to be able to get the notes and all that. Okay, that is this is just online class. This online class. I can't be waiting for you guys to keep on writing because one, there's no time. Now let's proceed further. Let's proceed further. Please write. Okay, so let's finish up now. I want to show us something. I would have left that diagram because I will need that diagram to evaluate a factor. Okay. Well, let me repeat the diagram. we have our diagram, right? Let me repeat the diagram, please. I'm repeating the diagram again for the conical pendulum. So here we have our diagram, right? We have this, don't forget. Then we have our height, okay, don't forget. Then we say this is the motion of the body. This is the mass height. The mass of the ball tends to act downward. The weight acts downward, which is what? Mg. Then we have our vertical force, which is what? Ty. Exactly. Our angle here is theta. This is also what? Theta. Okay, from here to here, we define here as R and here as L, right? Then we define this direction this way. Then also say here we have our tension. We also have our tensional force here. Exactly. Okay, then we have our direction this way. This is angle 90 degree. This forms a right angle triangle. If you look at this, I want to define something here. I can define the value of R. This side here that faces this angle is called R. Don't forget that this is also our TS, Abi. This is our TS, exactly. This is our tensional force, our TS. Okay. This is also radius from the center to this mass is called what? It's called the radius of a circle. It's called the radius R, right? The radius of a cone, But this is our radius from here to here is our radius. Now, if you look at this, we have that if the angle is here and this is the side here, right, which is called R, and here we have our length. Let's define this. I can use this. The value of my R represents what? The opposite. This is my opposite, right? This is my what? Hypotenuse. So I can use sine theta. So using sine theta, and sine theta represents from the word so, Abi, it means opposite over what? Hypotenuse. My opposite is R. R over what's our hypotenuse? Our L, right? Our L. So from here, I can cross multiply this. My opposite is R over L. Opposite over what? Hypotenuse. So R over L. I can cross multiply this, and that will give us R, okay, equals to what? L sine what? L sine theta. R equals to what? L sine what? Theta. Now, I've been able to define my value of R. I can then import this. This is equation 6. I can put this equation to replace what? R here. And that will give us what? Let's go. Sine theta over what? Cos theta equals to what here? 4 pi squared in brackets. Our R here is what? Is L sine what? Sine theta, all divided by what? T squared G, right? T squared G. From here, we have an equal sign here. Sine theta can go with sine theta. Okay, so if that is the case, we can be able to solve further. We are heading somewhere, we are almost done. We are able to solve further. If that is the case, that implies that we are left with what? 1 over what? Cos theta equals to 4 pi square L, right? 4 pi square L divided by T square G. From here, our aim is to make our period to stand alone as subject of the formula, right? Because we're looking for the period of what? Of oscillation. So let's go. So T squared G times 1 is what? By the time we cross multiply this to find our period, multiply. That will give us what here? T squared G, times 1 is T squared G equals to what? 4 pi squared L cos what? Cos theta, right? 4 pi squared L cos theta. The next is to divide both sides by what? By G. I have to do for me to eliminate this G. So I will divide both sides by G, right? Divide both sides by G. So G can cancel G. We are left with what? T squared equals to what? 4 pi squared L cos theta all divided by G. So our period becomes what? But the next thing we need to do is to square root both sides. It means period equals to square root of every value here, right? That will give us 4 pi squared L plus what theta, all divided by what G. We are not done because we can still evaluate further. Okay, by so doing, I cannot clean this diagram. Please make sure you are writing. By so doing, we cannot evaluate further. Our period becomes, if I'm to square root of 4, will give us what? 2, right? Give us 2. That will give us 2. Square root of pi square cancel square root. We are going to have what here? 2 pi, right? 2 pi. Then L cos theta will still remain as a root. We have 2 pi square root of what? L cos what? Theta. All divided by what? By G. Final expression. So we have been able to derive it. So this is the final expression. So our period for conical pendulum is 2 pi square root of what? L cos theta divided by what? G. You can see the long process it took us to get to this point. Okay, I want you to take your time, go through this. This is your past question, not my question. So that means that you can see this anytime. For them to even say this, that means they can give you something like this, or even something more than this. Or they might even repeat this same question, and you're expected to solve. So all I want you guys to do with the knowledge you have gathered, make sure you go through this for proper understanding. Let's see how we can solve a problem under this, right? Okay, let's solve a problem under this. Please, if you are following, indicate that you are following. If you are following, indicate that you are following. If you are getting it, say, I'm following, I am getting it. Okay. Let's solve a problem we have here. The question says that a theta ball, a theta ball spelled this way, of mass 2 kilogram. The mass is 2 kilogram. Is attached to a pole. It attached to a pole by a light string of length 2 meter. Our length is 2 meter. The ball is hit so that it moves in a horizontal cycle, forming a conical pendulum. I repeat again, a theta ball of mass 2 kilogram is attached to a pole by a light string of length 2.0 meter. The ball is hit so that it moves in a horizontal cycle, in brackets, forming a conical pendulum. So you should know where you're directing your formula to. They mention a conical pendulum, such that the string makes an angle of 30 degrees with the vertical pole, So you don't need to draw diagram, but if you can draw diagram, you can still draw. All right, but the angle of inclination is along the vertical axis. Okay, for the sake of lecture, let me just draw the diagram. This is our pole. Then we have the theta ball. We have the angle of inclination called theta, right? Then we have the motion of what? Of the ball in the circular path this way, right? The weight of the body is acting downward, which is mg. there's a force here, right? Which makes an angle theta. All right. Here we have this. We have this. We have our radius. We have our tx here, right? We have our ty here. I'm just defining all the force. Then we have the tensional force. The tensional force here is our capital T, meaning the sum of ts and ty equals to t, right? So yeah, what again? The angle you're giving is actually 30 degree. This also what? 30 degree. Okay, don't forget. Now we are now asked to find what? Yeah, we have to find calculate the period of rotation. Question one say calculate what? Period of rotation. Rotation. Number two says calculate the tension in the string. The tension in the what? In the string. Find the tension in the string. Find the tension in the string. This is very simple. So what we do is to recall. Our formula says T equals to what? 2 pi, right? Square root of what? L cos theta over G. A very simple equation. So period becomes 2 times the value of our pi is about 3 points, right? 3.142, 3.142, square root of what? The length is given as what? 2.0 or 2 times, we have cos what? Cos 30. Is that clear? Cos 30, right? Cos 30, all divided by what? 9.8. G is taken as 9.8. So our tension becomes, let's see what we can have here. Let's evaluate our answer. 3.142 times 2 will give us 6 points. Then we have 6 points. 284, right? Then we have square root of what here? Cos 30 is about cos 30 is about cos 30. Sorry, a little time. Give me a little time. Cos 30 is about 0.8660 times 2. Okay. Then divide the value by 9.8. That will give us about 0. Everything here is 0.17667. Okay. What we did here is that cos 30 is about 0.8660. Multiply that value by 2, divide by 9.8. That will give us about 0.1767. The square root of this answer is about what period? Our period becomes 6.284 times about 0.424204, right? Then times 6.284. Our final answer here, sorry. I'm always getting advert from my calculator. So let me remove it again. 6.284 times 0.4204. So this will give us about 2.6.
Okay, please let me just conclude. My battery is very low. I have to charge a little to come online again. So please let me just finalize. Already we have started the journey already. We have seen that our length is 2. We have cos 30 divided by 9.8, right? Then we have 2 times 3.142 is 6.284. When you evaluate this, that will give us 0.1767. The root of this is 0.4204. Then multiply by what you have here, it will give us about 2.64 seconds. Okay. Now number 2 says find the tension, right? Find the tension. You know, when we are resolving the vertical forces, we say that Ty equals to what? Mg. Don't forget that Ty equals to what? Mg. And I would like to explain that again. by, let me clean up this part. We say that Ty equals to mg, right? If I have a conical pendulum, okay, then we have our masses here, right? Then the we have our angle of inclination somewhere here. Then this is the motion of this bulb, right? The weight is acting downward, which is m equals to what? W equals to mg. Then we have a vertical force here that makes an angle theta, right? Are you there? Okay, then the tensional force is here. We say that from here to here is our radius of the circle, which is our tx. Then here we have our ty. Is that clear? Okay, then we say that for the vertical forces, that ty is equal to what? Mg. Okay, since the body is not moving vertically, the body is only moving horizontally, right? So we're only considering the vertical, okay? We're only considering the horizontal movement. But since the body is not moving it's not moving vertically, we are saying that our ty is equal to what? Mg, right? And we also say that acceleration of the body is equal to 0, that the body is not accelerating, that the value of a is equal to 0. So what ty is equals to what? Mg for the vertical. So if ty equals to mg, that implies that our t cos theta, right, is equals to what? Mg. Is that clear? So from here we can find our tension. That means our variable stand by what? By cos theta over what? Over cos theta. So this can go with this. That means our tension is equals to what? Mg divided by what? Cos what? Cos theta. Mg divided by cos theta. Alright? So don't forget. That was what I was doing before my battery actually disappointed me. So from here, our t equals to mg over what? Cos theta. We have gotten the value of our period, right? Now we have to find the tension. This is our tension. So from here we have mass is 2, gravity is 9.8 divided by cos 30. That will give us about 22.63. When multiply 2 by 9.8, we're going to have 19.6. Cos 30 is 0.8660. Then when you divide these two, we have 22.63. So I'm going to stop here for today. We'll meet tomorrow. We have been able to solve the IMSU past question. Then by tomorrow, the other ones we neglected, although we have already solved them, we solved them today at the tutorial. We just continue. So this is like a continuation of from where we stopped. So we have been able to exhaust 2024 past question. Maybe in our next class, we'll now look at 2023/2024 past question. Okay, then we'll also look at 2022. If you can be able to solve like 2 to 3 years or 4 years, I can trust the fact that you can enter the exam or do wonderfully well. Okay, all right. I believe that by the time we're able to solve like 2 to 3 years, you have so much boldness and so much confidence, okay, to be able to face any exam. So please, if you have any challenge or any topic you want us to talk about, please indicate it in the comment section. Indicate in the comment section if you have any topic you want us to discuss about. Are you guys following? Please, if you have any topic you want me to discuss about, indicate such topic in the comment section. Indicate such topic in the comment section. All right. If you have any question, you can ask your question. Please, you can ask your question. You can ask your question. You can ask your question. All right. And if you have any question, you can ask the question. If you have any topic you want us to discuss, you can indicate them in the comment section. So see you guys in our next class, right? See you guys in our next class. Thank you so much. So tomorrow's class will meet the same time by 8 p.m. Thank you guys.